Hi all, welcome to Heights to Fly. Today we are going to discuss some previous year questions and application based, that is important questions on chapter 1, that is the real numbers. Standard previous year questions on chapter 1 and application based questions. On previous classes we discussed about all the exercise and examples discussed in textbook. Today we are going to discuss previous year questions. First question, find the largest number which divides 70 and 125, leaving remainder 5 and 8 respectively. Find the largest number which divides 70 and 120, leaving remainder 7 and 8 respectively. That is, the number leaves remainder 5 and 8 on 70 and 125 respectively. So we have to subtract these numbers from the corresponding numbers. Then we will get this one. This number will be exactly divisible. Exactly divisible by that number. Okay. 70 is not exactly divisible. That is why it leaves the remainder 5. When 70 minus 5, which is equal to 65, that number will be exactly divisible by that particular number. Similarly, 125 minus 8, which is equal to 117, which is also exactly divisible by that number. Then by factorization, by prime factorization, we can say that factorization method, 65, we factorize 65, we'll get 513, 5 into 13. Then for 117, 3, 3, 9, again 3, 1, 3. Okay, 3 square into 13. Then we have to find out the HCF, highest common factor. What is the highest common factor? The least power, the common least power. That is, common least power means here 5 is not present here, so we have to skip it. 13 is present in both numbers, and the least power is 13 raised to 1, 13. Similarly, 3 square, 3 is absent in this number, so the HCF is 13. So the required number is equal to 13. Okay. And the second question, complete the following factor tree and find the composite number x. The tree given is x3, 195, 3, that is y, composite number x and y. Okay, question is x and y, 5, and the last one 13. You can find out the value by 5 into 13, which is equal to 65, and again x equal to 195 into 3, which is equal to 585. Okay, this is the method to find out the values in a factor tree. Okay, let's go to the next question. Next question is, can two numbers have 15 as their HCF and 175 as their LCM? Okay. Can two numbers have 15 as their HCF and 175 as their LCM? Let's go to the definition of LCM and HCF. What is LCM? The product of highest power of each factor involved in the numbers. We know that the product of highest power of each factor involved in the number. HCF is the product of smallest power which is common in both numbers. So definition is not necessary for this to solve this number, that I just solved it. Then LCM is equal to K into HCF. From this definition we can write it as LCM is equal to K into HCF, where K is an integer. Then here the value LCM given is 175 and HCF given is 15. So LCM is equal to 175 is equal to K into 15. Then K is equal to 175 divided by 15, which is equal to 11.67, which is not an integer value or not a whole number. So we can say that these two numbers, therefore these two numbers are not common in LCM and HCF, or two numbers cannot have 15 as their HCF and 175 as their LCM. Okay, so our answer is no. And the next question, the question is somewhat lengthy, so I already written it. 3 bells toll at intervals of 9, 12, 15 minutes. If they start tolling together, after what time they will next toll together? 3 bells toll at intervals of 9, 12 and 15. If they start tolling together, they start same time. After what time they will next toll together? Because they have a different intervals. 9, first bell will ring at 9 minutes, second will ring at 12 minutes and third one will ring at 15 minutes. But initially the first bell starts at the same time. 3 bells ring at the same time, and after 9 minutes the first bell ring, after 12 minutes. The question is, after what time they will next toll together? Togetherly they will ring at which time? So we have to take the LCM of this value. Such kind of questions we have to find out LCM. So 9 is equal to, we can represent it as 3 into 3, which is equal to 3 square. 12 is equal to 4 into 3, and 15 is equal to 3 into 5. Then we can represent the LCM as 3 square into 4 into 5, the largest power in all factors. Then we can say that 9 into 4 into 5, which is equal to 180 minutes, which is equal to 3 hours. So they will next toll together after 3 hours. Okay, such kind of questions we have to find out LCM. We find out the LCM and convert it into hours. 60 minutes is equal to 1 hour. So 180 minutes is equal to 3 into 60. And next question. 2 tankers contain 850 liter and 680 liter. Find the maximum capacity of a container which can measure the petrol of each tanker in the exact number of times. Find the maximum capacity of a container which can measure the petrol of each tanker in the exact number of times. Here we have to find out the HCF. HCF of 850 and 680. Okay, we can represent the number 850 as 850 divided by 5, 1, 7, 0, again 5, 3, 4, 2, 17. Okay, and the second number is 680, 2, 340, 2, 170, 2, 65. Number is 170, 85, 137, 35, 7. Okay, let's write it as 5 square into 2 into 17 and 680 as 2 raised to 3 into 5 into 17. So the HCF is equal to 5 into 2 into 17 is equal to 170. That is the maximum capacity of the container is equal to 170 liters. Okay. Our next question is important. If two positive integers x and y are expressible in terms of primes as x is equal to, if two positive integers x and y are expressible in terms of primes as x is equal to p square q raised to 3 and y is equal to p raised to 3q. What you can say about the LCM and HCF? Is LCM a multiple of HCF? Before this question, we discussed about LCM is equal to K into HCF. Such a pattern is following here. And the value of x is equal to p square q raised to 3 and the y is equal to p raised to 3q. It's already given in the question. It's LCM. From this two values we can write the LCM as p raised to 3 into q raised to 3, largest power, p raised to 3, and considering this is q raised to 3, and HCF is equal to smallest power from both these terms, p square and q. Let's express the LCM in terms of HCF as HCF is p square q then p q square. This is the HCF value, so we can say that LCM is equal to, our expression is LCM is equal to K into HCF. So we have to represent like this. LCM is equal to, what is the HCF value? P square q. After eliminating p square q, the K value becomes p q square, p raised to 3 and q raised to 3. Okay, then p q square into HCF. So we can say that LCM is a multiple of HCF. Let's prove through an example. Consider, let A equal to 12. We can represent 12 as 2 square into 3. And B is equal to 18, which is equal to 2 into 3 square. HCF is equal to 2 into 6, which is 2 into 3, 2 into 3, which is equal to 6. And LCM is equal to 2 square into 3 square, which is equal to 36. Then we can represent LCM is equal to K into HCF. 36 is equal to k into 6, k is equal to 6. That is LCM is 6 times of HCF. We proved the above condition. Once again, we take the values x and y, then LCM taken, it have to be expressed in the form of k into HCF. It is possible in that case because p square q into pq square, which is equal to p raised to 3 q raised to 3. So LCM is a multiple of HCF. And let's go to the next question. Let's go to the next question. Show that on and only 1 out of n plus 1 and n plus 2 is divisible by 3, where n is any positive integer. You have to show that one and only 1 out of n plus 1 and n plus 2 is divisible by 3, where n is any positive integer. Okay, let's go to the solution. Let n plus 1, n plus 2 be 3 consecutive positive integers. Suppose these are 3 consecutive positive integers. If it have to be divisible by 3, divisible by 3, 3q plus 1, 3q plus 2, we can represent in this form. Okay, case 1, we are taking the value n is equal to 3q. First value n is equal to 3q. Here, according to our previous condition, n is divisible by 3, and this is 3q, n is equal to 3q, so it is divisible by 3. Okay, so if 3q is divisible by 2 or n is divisible by 3, n is divisible by 3, that is 3q is divisible by 3, therefore n is divisible by 3. If n is divisible by 3, then we can say that n plus 1 and n plus 2 are not divisible by 3. Am I correct? Consider the number 6. We can represent it in the form of 2 into q, right? 3 into 2. 3 into 2. Such a number is divisible by 3. But 6 plus 1 and 6 plus 2, which is equal to 7 and 8, are not divisible by 3. Yeah, such a condition is proved. Next, case 2. Take n is equal to 3q plus 1, or second value, 3q plus 1. Then n plus 2 is equal to 3q plus 3, which is equal to 3q plus 1 plus 2. Right, 3q plus 3. So we can rewrite it as 3 into q plus 1. Okay, 3 into q plus 1. Then it is also divisible by 3. So n plus 2 is divisible by 3. But if n plus 2 is divisible by 3, then n and n plus 1 are not divisible by 3. 9 is divisible. This is such a condition. 9 is divisible by 3, then 7 and 8, n plus 1 are not n plus 2. This is n plus 2. N plus 2. Then 7 and 8 are not divisible by 3. And the last case, case 3, n is equal to 3q plus 2. Okay, n plus 1 is equal to 3q plus 3. Again, we can represent it as 3 into q plus 1. Therefore, n plus 1 is divisible by 3. And if n plus 1 is divisible by 3, n and n plus 2 are not divisible by 3. So it is proved that in all the three cases we proved the above condition. Hence, we can say that one and only one out of n plus 1 and n plus 2 is divisible by 3. The above condition is proved. Okay. Let's go to another question. Find HCF of numbers. Find HCF of numbers 134791, 6341 and 6339 by Euclid's division lemma. Okay, here three numbers are given. So consider the numbers 134791, 6341 and 6339. Okay, let's take the two numbers, this one and this one. Okay, 6341 is greater than 6339. So we have to express it in the form A is equal to BQ plus R. A is equal to BQ plus R. This is the Euclid's division lemma. 6341 is equal to 6339 into 1 plus 2. Then 6339 is equal to 3169 into 2 plus 1. 3169 is equal to 3169 into 1 plus 0. 3169 into 1 plus 0. So the remainder, non-zero remainder we got is 1. So the HCF of 6341 comma 6339 is equal to 1. Again we have to find the HCF of 134791 and 1. Okay, 134791 is equal to 134791 into 1 plus 0. So HCF is equal to 1 itself. HCF is equal to 1. Okay. Next question. Amita, Sneha, Raghav start preparing cards for all persons of an old age home. In order to complete one card, they take 10, 16 and 20 minutes. 10, 60 and 20 minutes. If all of them started together, after what time will they start preparing a new card together? Okay, they start at the same time and their intervals are this time, and at what, if all of them started together, after what time they will start preparing a new card together? This is a similar question we discussed it as a time for 5 minutes, 9 minutes, 15 minutes like previous question. So we have to find same pattern question we already discussed. 16 and 20. We will get 10 is equal to 2 into 5, 16 is equal to 2 raised to 4 and 20 is equal to 2 square into 5. LCM is equal to 2 raised to 4 into 5, which is equal to 80 minutes. Similar question we already discussed. Next question. Dudnath has two vessels containing 720 ml and 405 ml of milk respectively. Milk from these containers is poured into glasses of equal capacity to their brim. Find the number of glasses that can be filled. He has two vessels to measure milk containing milk. Milk from this container is poured into glasses of equal capacity to the brim. The full glass is measured. Find the number of glasses that can be filled. Okay, the vessels are measuring 720 and 405. We have to find the HCF of 720 and 105. 720 is equal to 2 raised to 4 into 3 square into 5, and 405 is equal to 3 raised to 4 into 5. Then HCF is equal to 3 square into 5, which is equal to 45. So the capacity of glass is equal to 45 ml. Number of glasses required. Then the question is find the number of glasses. Number of glasses filled from first vessel is equal to 420 divided by 45. The whole measure is 720. 720 divided by the glass measure, which is equal to 16. It's again 720 divided by 45. 3, 15, 2, 40, 5, 3, 1, 6. Okay, 16. And for the second vessel, number of glasses equal to 405 divided by 45, which is equal to 9. Okay, so total number of glasses is equal to 16 plus 9, which is equal to 25. Okay, first we find out the capacity of the glass by using the HCF, then the number of glasses for the first vessel, which is equal to total measure divided by the glass measure. Here also the same, then the sum of these two values. Next question. There are 104 students in class 10 and 96 students in class 9 in a school. Okay, so the number of students in class 10 is 104 and class 9 is 96. In a house examination, the students are to be evenly seated in parallel rows such that no two adjacent rows are of the same class. The condition is no two adjacent rows are of the same class. Find the maximum number of parallel rows of each class for the seating arrangement. First question, find the maximum number of parallel rows of each class for the seating arrangement. Okay, then find the number of students of class 9 and also of class 10 in a row. And the last one is, what is the objective of the school administration behind such an arrangement? Okay, let's go to the first question. Find the maximum number of parallel rows of each class for the seating arrangement. Okay, first we have to find out the HCF of the values. Values given are 105 and 104 and 96. HCF is equal to, we can represent 104 as 2 raised to 3 into 13 and 96 as 2 raised to 5 into 3. So HCF is equal to 2 raised to 3 into 8. Okay, 2 raised to 3, the values are 3, which is equal to 8. Highest power is 2 raised, smallest common power is 2 raised to 3. Here 13 and 3 So we can't take 13 and 3. Only the common value is 2 and the least power is 2 raised to 3. So we take it as 2 raised to 3 is equal to 8. And let's go to the first question. Find the maximum number of parallel rows of each class for the seating arrangement. Okay. The number of rows of students of class 10 is equal to 104 divided by 8. The total number of students divided by the common value, which is equal to 13. Similarly, of class 10 or class 9 is equal to 96 divided by 8, which is equal to 12. So total number of rows is equal to 13 plus 12, which is equal to 15. Here we get the HCF value as 8. So the number of rows required for class 10 students are 104 divided by 8, and for class 9, 96 divided by 8. So we find out the total number of rows. And the second question is, you find the number of students of class 9 and also class 10 in a row. Okay. Here we find out already the HCF, which is equal to the number of students of class 9 in a row equal to 8. Similarly, class 10 is equal to 8. Okay. And the last question for the third subpart. What is the objective of the school administration behind such an arrangement? It's not a mathematical question. No. Then can take help from any other student of his or her class. This is a simple objective. Next question. Using Euclid's division algorithm, find whether the pair of numbers are numbers 847 2160 are co-prime or not. Have to check two numbers 847 and 2160 are co-prime or not. What is co-prime? Co-prime means two numbers have only the common factor as 1. One is the only value which is common to these two numbers, then it can be called as co-primes. Let's take HCF here. Okay, A equal to BQ plus R. We have to express it into the form 2160 is equal to 847 into 2. Okay, plus 466. We already discussed a lot of this methods, Euclid's division lemma algorithm, in previous classes. That's why I directly writing the method. 847 is equal to 466 into 1 plus 381. 466 is equal to 381 into 1 plus 85. 381. I will provide the link to find how to find the HCF of two numbers using Euclid's division algorithm. It will be provided in the link of the link in the description part. So please find out it. 5 into 4 plus 41. 85 is equal to 41 into 2 plus 3. 41 is equal to 3 into 13 plus 2. 3 is equal to 2 into 1 plus 1. 2 is equal to 1 into 2 plus 0. Here the non-zero remainder, here the remainder value is 0, the non-zero remainder is 1. This is 0, so we have to go to the previous remainder, which is equal to 1. So HCF is equal to HCF of 2160, 847 is equal to 1, which means these two numbers are co-primes because the highest common factor is equal to 1. No other numbers are not factors of these two numbers. Next question. The length, breadth and height of a room are 8 meter 50 centimeter, 6 meter 25 centimeter and 4 meter 75 centimeter respectively. Length, breadth and height are given. Find the length of the longest rod that can measure the dimensions of the room exactly. Here also we have to find out the HCF. Okay, we can represent length as equal to 8 meter 850 centimeter, 8 meter 50 centimeter, which is equal to 850 centimeter. 1 meter is equal to 100 centimeter, so 800 plus 50, 850. Similarly, breadth is equal to 625 centimeter and height is equal to 475 centimeter. Okay, we can represent 850 is equal to 2 into 5 square into 17, and 625 is equal to 5 raised to 4, and 475 is equal to 5 square into 19. So HCF of 850, 625, 475 is equal to highest factors 5 square. Here 5 square, 5 raised to 4, 5 square. The common factor is 5 square, 2. There is no 2 value and there is no 17 and there is no 19 all common. So the common value is only 5 square, so 25. So the length of longest rod is equal to length of longest rod is equal to 25 centimeter. Okay. Next question. If the HCF of 408 and 1032 is expressible in the form 1032 into 2 plus 408 into P, then find the value of P. Once again, if the HCF of 408 and 1032 is expressible in the form 1032 into 2 plus 408 into P, we have to find out the value P. Okay, first we have to find out the HCF of 408 and 1032. Based on Euclid's division lemma, we can find it as the value 24. So we can express this as 1032 into 2 plus 408 into P is equal to 24, and 408 P is equal to 24 minus 1032 into 2, which is equal to 2064. P is equal to 24 minus 2064 divided by 408, which is equal to minus 5. So we can find out the value P. First we find out the HCF of 408 1032 using Euclid's division lemma. Then we substitute the value in this expression, because this expression is equal to the HCF. Then we simplify it for the variable P. Next, the decimal expression of the relational number 4 raised to 3 divided by 2 raised to 4, 5 raised to 3 will terminate after how many places of decimal. Once again, for the real number 4 raised to 3 divided by 2 raised to 4, 5 raised to 3 will terminate after how many places of decimal. So we have to convert this. Okay. Four raised to 3 divided by 2 raised to 4. We have to take the power common. 5 raised to 3. 5 here, 5 raised to 3. We can multiply and divide using value 5. 4 raised to 3 into 5 divided by 2 raised to 4 into 5 raised to 4. Here the powers are same, which is equal to 4 raised to 3 into 5 is equal to 215 divided by 10 raised to 4. We get the factor term 10. So 10 raised to 4 is equal to 10 raised to 4. There are 4 decimal portions. So we can say that after 4 decimal places. 4 decimal places. Let's discuss some one mark questions. The sum of a relational and an rational, sum of a rational and irrational number is the sum of a rational and irrational number is irrational number, that is 2 and root 5. It is a rational number. Example. Next, a lemma, it is a previous question, all these are previous questions, is an axiom used for proving, our options given are other statement, B no statement, C contradictory statement, and D none of this. Our question is, a lemma is an axiom used for proving. The answer is other statement. It is used to prove other statements. Okay. If HCF of two number is 1, then the numbers are called, we previously discussed one of the question relating this. HCF of two numbers is 1, then we can say that it is relatively prime, or another term is coprime. Next question, 2.35 is a rational number. It is a rational number. But 2.13113, 1113, 111 is an irrational number. An irrational number. Please all note all this type of questions. The smallest composite number is, our options given are 1, 2, 3, 4. The smallest common composite number we considering is 3. Next question, pi is which type of number? A rational number, irrational number, composite number? It's an irrational number. Irrational number. When we are expanding pi, we will get a pattern like this, continuously going pattern. Another question, 2 plus root 5 is an irrational number because it is a composition of rational number and irrational number, combination of rational and irrational number. So we can say it as an irrational number. Next question. Find the value of, important question, find the value of minus 1 plus minus 1 the whole raised to 2n plus minus 1 the whole raised to 2n plus 1 plus minus 1 the whole raised to 4n plus 1, where n is any positive odd integer. Once again, find the value of minus 1 plus minus 1 the whole raised to 2n plus minus 1 the whole raised to 2n plus 1 plus minus 1 the whole raised to 4n plus 1. Okay. Here the condition given is n is any positive odd integer. So we can say that minus 1 the whole raised to n is equal to minus 1 because n is positive odd integer. Similarly, minus 1 the whole raised to 2n is equal to 1 or plus 1. Then minus 1 the whole raised to 2n plus 1 is equal to minus 1 the whole raised to 2n into minus 1 the whole raised to 1. A raised to m into a raised to n form, which is equal to, which is already given, 1 into minus 1, which is equal to minus 1. And the last case, minus 1 the whole raised to 4n plus 2, which is equal to minus 1 the whole raised to 4n into minus 1 the whole square, which is equal to 1 into 1, which is equal to 1. When we substitute in the equation 1, we will get it as minus 1 the whole raised to 1, which is equal to minus 1 plus minus 1 the whole raised to 2n, which is equal to 1, minus 1 the whole raised to 2n plus 1, which is equal to minus 1 plus minus 1 the whole raised to 4n plus 1, which is equal to 1. We get the value as 0. It's all completely depends on the odd positive odd integer. N is any odd positive integer. That is the basic condition here. So we get the values like this. Next question. Show that root 3 plus root 5 the whole square is an irrational number. Okay. First we have to convert root 3 plus root 5 the whole square, which is in the form a plus b the whole square, 3 plus 5 plus 2 root 15, which is equal to 8 plus 2 root 15. Here we are using the method proof by contradiction. Consider this as a rational number, and a and b are considered, let a and b are two rational numbers, two integers, and co-primes also. Then, and the value of b should not be equal to 0. A divided by b is equal to 8 plus 2 root 15. 2 root 15 is equal to a divided by b minus 8. Root 15 is equal to a minus 8b divided by 2b. Okay. A minus 8b divided by 2b, according to our initial prediction or initialization, it is a rational number. If this is a rational number, then root 15 is also a rational number. But root 15 is an irrational number actually. So this prediction is this statement is false. This statement is false. So this assumption is also false. So we can say that according to proof by contradiction, 8 plus root 15 is an irrational number. Okay. Therefore, root 3 plus root 5 the whole square is an irrational number. We discussed a lot of this type of questions, that is taking A, B, then this form, proof by contradiction method. We discussed a lot in previous classes. Okay, please go through the description, a link provided in the description also. And the last question, if HCF of 144 and 180 is expressed in the form 13m minus 3, find the value of m. If question is, if the HCF of 144 and 180 is expressed in the form 13m minus 3, find the value of m. Similar question we already discussed according to Euclid's division algorithm. Numbers 180 and 144 equal to BQ plus R. 180 is equal to 144 into 1 plus 36. Okay. 144 is equal to 36 into 4 plus 0. Here the value remainder is 0. So we have to go to the previous non-zero remainder. So the HCF is equal to 36. Then we can substitute the expression in the form 13m. HCF is expressed in the form 13m minus 3. So 13m minus 3 is equal to 36. 13m is equal to plus minus 3, which becomes plus 3. 36 plus 3, which is equal to 39. M is equal to 39 divided by 3, which is equal to 13. Which is equal to 39 divided by 13, which is equal to 3. Which is equal to 3. So the value of m is equal to 3. Okay. These questions are a section of previously discussed questions. All questions discussed in textbook and the exercise questions in textbook are very important. That is, in textbook there are a lot of proofs and questions like this are mentioned. All these questions are important because all that questions are asked in previous years. So these questions are additional questions, which are application based questions, which are not provided in the textbook. That is why I discussed in this video. Okay, thank you for watching. Thank you for watching. Subscribe and share for new videos.